Hello, in this video we review the difference between a function and a plain old relation. Let's get started. So recall that to be a relation, we're just talking about a point, xy, or a group of points of the form xy, where your x values are mapped to your y values and vice versa. We say that the x values are known as your domain, your inputs, and your y values are known as your range, or your outputs. So for example, if we use set notation, those braces, and we had some points inside of the set, like the point 3, 1, 2, 5, -4, 2, -1, 0, and 3, -4. You can click on the Desmos link in the corner of your notes, and you would see those points plotted. You could also plot them yourself. What we've noticed here is that we have what we call a relation, meaning the x's are getting mapped to the y's. So what we have here, if we were asked to find the domain, we could open up our, let me go back here. We could open up our braces, and inside of our braces, we would simply insert all of the x values or the inputs which are mapped to these outputs, these y values. So I would start typically, good notation is to start with your smallest input, which appears to be a negative number, -4. So I would stick -4 here. And then the next largest number, so you're moving from left to right, it appears to be -1. Followed by the next largest x value, which appears to be 2. And then notice that we have two x values which are the same, but they're getting mapped to different locations. That will be very interesting. 3 is getting mapped to -4, but it's also getting mapped to an output of 1. We're going to learn in a moment that this is not a function because every input for a function should only be mapped to one output. This is still a relation, however, and we would just write 3 one time because that input is the same in both cases. It's still the input of 3. For our output, that would represent the values of our range. So for the output, we would look at our y values, 1, 5, 2, 0, and -4. And to write our range in the set notation, we would open our braces and simply write, once again, from left to right, small to large, separated by commas, each value which is an output in this mapping or relation. The smallest output that I see is -4, right here. So I would put my -4 there, followed by what? Let's see, we have 0, 2, 5, and 1. Looks like 0 would come next, wouldn't it? Followed by 1, just good notation here, followed by 2, and then finally the output of 5. So you can see here that there are only 4 inputs, but there are 5 outputs, which implies that one of those inputs is getting mapped to multiple outputs. Okay, so that is what we mean by domain and range when it's simply a set of discrete points. Discrete means countable, right? They're not continuously flowing like a line or a curve. These are just points. So we simply take our x values and our y values and we put them in sets. All right, that was easy enough, I hope, for you. Let's head over to our next slide. Now we're going to talk about a special relation which is called a function. And as I alluded to in the first slide, a function is a special relation where each value x in your domain, actually let me use blue so I'm consistent with our first slide, for our domain was in blue, I believe. Each value x in the domain is getting mapped to exactly one output y in the range. And I'll put that in red. Now exactly one is the key terminology here. If you have multiple outputs for a single input, like we did in the last slide, that would not be called a function. It would still be a relationship or a relation in mathematical language, but it would not be a function. So if we take a look at what we have below with this example, we see another set of points. And for the first point, we have -1, 4. For the second point, 2, 3. The third point, 3, 4. And the fourth point, -4, 5. Well, if I were to list the domain here, like we did in the last slide, I would begin by noticing the smallest x value for our input is -4, followed by -1. You could pause it and do it yourself, of course, followed by 2, and then 3, right? But for our outputs, let's see what we're getting. We have an output of 4, 3, 4, and 5. Now this time we have outputs which are repeated, right? The output of 4 is repeated, but there are no inputs which are getting mapped to the same output or to different outputs, to multiple outputs, I should say. So what would you say the range would be from small to large in this set? Yep, you'd start with your smallest output of 3, followed by the next largest of 4, which happens twice, but you only need to write it one time, followed by the output of 5. So the set 3, 4, 5 would be the set of all outputs for this function. Now notice here that if you were to graph those points, and you can see it if you click on the Desmos link in the notes, you would end up with a situation where you have -1 getting mapped to 4, 2 getting mapped to 3, 3 getting mapped to 4 again, and -4 getting mapped to 5. I'll just do a quick little sketch so you can see what that looks like by hand. At -1, at that input, we are mapped to the output of 4. So let's go up 1, 2, 3, 4. So that is that location. At +2, we are mapped to an output of 3. So that would be like this location. All right. At +3, we are being mapped to an output of 4 again. Interesting. So that would be this location. And finally, at the input -4, we were being mapped to, I get 4 here? 1, 2, 3, 4, there we go. -4, we were being mapped to the output of 5, right? So let's go up a little bit more. There's 5. So -4 was mapped to an output of 5. Now what I noticed with those points is that for each input, we're only going to one output, right? If I had looked at the last slide, at that input I think of 3, we had multiple outputs there. One way to think about functions, to recognize if you have a function or just a relation, think about birthdays, right? If you had a class of 30 students and I were to ask each person what their birthday was, each person would have how many birthdays? Just one. So each input, the people in the classroom, would have exactly one output, right? That is the definition of a function. Now, is it possible, that meets the definition, is it possible that there is someone else in the class that shares your birthday? Yes, you could share the same output, couldn't you? But you yourself can only have one output. That's what we mean by function. Another example is if a car dealership is looking at how many cars they sell per day. On Monday, they sell 5 cars. On Tuesday, they sell 6 cars. On Wednesday, they sell 9 cars. And on Thursday, they sell 5 cars again. Well, on, I think Monday and Wednesday, I forgot which day I was on, but on one of those days, they had the same number of car sales, the same outputs. That would still be a function because on each day, we only have one output. On each input, there is only one output. If you need to go to sleep saying that to yourself at night, a function is a relation where each input has exactly one output. That's what we mean. We'll talk about function notation in a future video. Now, if you're looking at the graph, do you notice that if you were to draw a vertical line through any one of the points on your graph, so for example, a vertical line through that location, or through that location, or through this input, or this input, or this input, you would only hit the point on that graph one time. That means it has passed what we call, over here on the left side of the screen, the vertical line test, which says that a graph represents a function if there are no vertical lines that intersect the graph at more than one point. So you can see the differences between these two pictures above me. You can see that the first picture above me on the left would be considered a function because at any location on that graph, if you put a vertical line through it, it would only hit the graph one time. But on the other hand, the kind of snake-like figure that's kind of look like an S, right? That would definitely fail the vertical line test. At this input in particular, it has 3 outputs, doesn't it? That fails the vertical line test because at each input, you should only have one output to be truly a function. We'll talk about special functions, which are one-to-one, in future videos toward the end of the semester, because in those cases, we have something called an inverse relationship possible. Okay, let's see if you can continue identifying whether or not you have functions using the information we've just presented on the next example. Feel free to pause the video and try it yourself. Example 1 says, determine whether the relations below are also functions or maybe not. So you have 3 pictures on top, A, B, C, you have another picture in D, and you have a set in E. So go ahead and pause the video, see if you understand your functions, and then we'll see how you did. All right, let's see it. In the first case, the x values here, these would be in your domain, wouldn't they? Your x values would consist of 1, 3, and 5, while your range or your y values are simply the outputs of 2 and 4. So the input of 1 is mapped to the output of 2, the input of 3 is mapped to the output of 2 again, and the input of 5 is mapped to the output of 4. Was this a function, yes or no? Yes, the answer is it was a function. So this was a function, and why was it a function? because every input got mapped to exactly one output. Does it matter that you share a birthday with someone? No. Similarly, it doesn't matter that person 1 and person 3 are both born in February. The key is that they both have exactly one birthday. Exactly. All right, take a look at B. What did you say for B? Again, the domain for B would be consisting of -3 and -6. In order, it would be -6, -3 technically. While the range consists of the outputs 11, 13, and 9. And in order, it would be 9, 11, and 13. Okay, would that have been a function? Yes or no? Well, -3 gets mapped to one output of 11. So far, so good. But look what happens to the input -6. He gets mapped to two outputs. Can you have two birthdays? Nope. So this is not a function. So we would say this is not a function because there is an input which gets mapped to multiple outputs. If you were to visually show this graph, those 2 points, it would fail the vertical line test at that input. So this is not a function for those reasons. Okay, what about C? Just looking at the graph, could we tell whether or not that was a function? Okay, the answer is yes, because if you put a vertical line anywhere through that graph, it doesn't matter what input you pick, how many times do you touch? Exactly once. So we would say yes, C is a function. All right. What did you say for D? Not a function? Good job. That is not a function. Why? It's not a function because it fails the vertical line test. You can see it failing right here at the input of 1, right? It hits twice. It hits more than once. It fails again at the input of 4. It hits at 2 locations. So it fails the vertical line test. In other words, at least one input, it has multiple outputs. And finally, for E, would this be a function? You have the points 4, 4, 9, 9, 6, 6, and -5, 9. So your domain would be 4, 9, 6, and -5, but in order from small to large. And your range would have been 4, 9, 6, and 9, but again, you wouldn't repeat them and you put them in order. So to answer the question, this would in fact be a function because every single input got mapped to exactly one output. So that will be critical to understand what a function is going forward in our future videos as we review function graphs and move them around. You will need to first know whether or not you have a function. So knowing when you have one is critical, and it's a skill you'll need to practice because, as always, math is not a spectator sport. So practice. I'll see you next time.